Hello, still you're talking about complex numbers. Now we'll see how to divide complex numbers. But first let's see what is complex conjugates. For example, if you have a complex number which is a plus bi, the conjugate for this complex number will be a minus bi. That means here the real part will be as it is, but the imaginary parts, its sign is going to be the opposite. That means if it is plus, change it to minus. Let's say, for example, let's say that you have 2 plus 5i, so the conjugate will be 2 minus 5i. Another example, let's say you have 4 minus 3i, so the conjugate is going to be 4 plus 3i. So here, as I told you, the real part will be as it is, but the imaginary part sign will be changed. Now let's see how to divide complex numbers. Okay, if you want to divide a plus bi divided by c plus di, first thing you have to find the conjugate of the denominator. That means the conjugate of the denominator, then this conjugate multiplied by the numerator and the denominator. That means here you'll have a plus bi over c plus di multiplied by c minus di over c minus di. So it will be the conjugate of the denominator that will be multiplied here. Once we start multiplying, I'll start with the numerator. You have a times c, ac, a times negative di, bi times c. Here negative b, b times negative d will give you negative bd, and here I times I will give you I squared. Okay, next I will go to the denominator. C times c, c squared, c times negative di, di times c. Again here d times d will give you, of course there is a negative here, negative d squared, and I times I will give you again here I squared. So don't forget what I told you in the last video, that I squared means negative 1. So here I squared is negative 1. That means the whole thing here will be multiplied by negative 1. So negative times negative will give you plus bd. Here c squared minus cdi plus cdi will be cancelled out because they will give you 0. And this is negative 1 times negative d squared will give you positive d squared. Okay, so here I will only just collect the like terms, collect the real parts together and the imaginary parts together. So what's the real part here? AC and BD. And what's the imaginary part here? This one. Good. So now here I gather together the real part, which is AC and BD. In the imaginary part alone, BC minus AD here, and the denominator will be a pure real part, C squared plus D squared. Okay, now I'll give you an example on this one. Let's have an example. Okay, let's say you want to divide 2 plus 3i by 4 minus 2i. As I told you, I'm going to multiply here by the conjugate of the denominator, which means this minus will be changed to plus. That means 4 plus 2i over 4 plus 2i. Okay, now here let's start multiplying. 2 times 2 will give you 8. 2 times 2i, 4i. 3 times 4, 12i. And 3 times 2 will give you 6, and I squared will give you negative 1, which means negative 6. And here use the shortcut, which is here it will be just c squared plus d squared. Forget these I parts, because as I told you it will be a real part. So 4 squared it will give me 16, and 2 squared will give me 4. That's all. For the denominator there is no need to multiply each and everything, just every time make c squared plus d squared. Whatever the sign here and here, just make between them a plus in the here. It will be c squared plus d squared. Okay. In the numerator I will collect the like terms. These are the real parts, 8 and negative 6. And the imaginary parts are 4 plus 12 I. 16 plus 4 will give me 20. Okay, so here we'll have 2 plus 16i over 20. But I want you here to separate them to make it easier. It will be 2 over 20 plus 16 over 20i, so that I can easily speak which part is the real part and which is the imaginary part. If you simplify here, you'll have 1 over 10 plus, again here simplify by 4, you'll have 4 over 5 I. So the real part is 1 over 10 and the imaginary part is 4 over 5 I. Okay, I'll give you a question that I want you to try by yourself, like divide. Uh, 5 plus 2i over 3 minus I, and here 3 minus 2i over 4 plus 5i.